Dear students, today we will discuss about e-content of Applied Physics 2, Semester 2, Unit 6, Semiconductor Physics. And now the content I am discussing about 6.2 unit PN junction diode VA characteristics, diode as rectifier, half wave and full wave rectifier, centrally tapped, and the circuit symbol. Now I am discussing the thing. mm, See the matter. The PN junction diode. PN junction diode, at first you should know the P-type and N-type semiconductor already discussed, or you have know these type things. P-type semiconductor is the semiconductor which contains holes as a majority carrier, and N-type semiconductor is the semiconductor which contains electron as a majority carrier. When a semiconductor doped in such a way that one side contains majority carrier as a holes and another side contains majority carriers as electrons, then these materials produce a PN junction. This is the junction, this is the junction, and this is called PN junction. This device is very important today's physics and today's technology. One thing, when current, when a battery or current pass from anode to cathode, then P-type, this junction barrier becomes very thin and we get the current. But when current pass from cathode to anode, then its junction barrier becomes wide, very large, then no current passes, that is block the current. So in one direction, this device, in one direction current passes, but in reverse direction current blocked. Now the symbol in our circuit, the P type is like that and N type is like that. This symbol is called PN junction diode. Now the characteristics, how it works, we actually represents this diode in graphical representation. This is called junction diode VI characteristics. As I have already discussed, the diode works in only forward region. When voltage applied in positive side, P side, to anode to cathode, means when voltage positive, when a battery applied, uh, when the positive terminal of the battery applied inside in P side and negative terminal connected to N side, then current passes through the diode. But when battery is reversed, then current will be blocked through the diode because current passes from N type to P type. But I have already discussed the diode only passes from current towards P type to N type, no N type to P type. So we get these characteristics. This is junction diode VI characteristics. When a battery applied, when its velocity voltage is increasing, then its current increasing, and at time one saturation current we get, and this is its active region, that is forward region. But when we apply the battery reversed, then the diode blocks the current. So a few amount of current passes and no current will be passed through the diode like forward region. And if we put more high voltage, then the PN junction diode will be destroyed. To get the reverse current, this diode will be doped in another way, then the diode will be called as Zener diode. Now forward bias. The forward bias, here I am discussing in details. This is P-type region where positive holes are majority carriers. This is N-type region when electrons are the majority carriers. These are electrons. Now in the junction, due to diffusion, the some electron comes in p type region and some holes come to n type region, and these two region, these two barrier, electron wall and holes wall, makes a barrier. This is called depletion region. When a battery applied to positive terminal to the p side and negative terminal to n side, then the depletion region becomes too much narrow, so current passes through the diode easily. But in reverse bias, what happened? Battery connected in reverse direction, like so which was in forward direction, but in reverse direction the battery direction is changed. This positive will be here, positive changed. So the depletion region will be wide because when electron was here, this electron, more electron will be come here due to this battery potential, and the potential barrier will be increased, that is wide depletion region, and no current will be flow through this diode, and the very few amount current will be flow, that is called no current will be flow through the diode. So we should remember, in forward bias diode PN junction diode is active, and in reverse bias PN junction diode is inactive. No current will flow through this diode. Now the diode as a rectifier, due to its property, it passes the current in only one direction but blocks the current in reverse direction. The diode acts as a rectifier. How? When the AC current is applied in the primary circuit, then due to induction, the current will be here, and due to first half cycle, for first half cycle, current will be passed through the diode. Diode will be on, activated, and goes through the load, and we get the output. But when in negative second half cycle, for second half cycle, the current will pass through this, and the for circuit completion, due to circuit complete, current will be flow if circuit will be completed, so current will pass through this thing, this load, and goes through the diode, but this diode blocks the reverse current. So due to second half cycle, no current will be flow due to it is blocked by the diode. So we don't get, as circuit is not completed, so no current will be flow, so we don't get the reverse current, only forward current we get. So we get the only we get the current load output only for first half cycle, so we draw only the first half cycle. Now full wave rectifier, in full wave rectifier centrally tapped, we used two diodes. For first half, this is the primary circuit, this is secondary circuit. When the current AC current is applied, then for first half cycle, this D1 is activated, but current blocks by the D2, so D2 is off. So no problem. The current will pass through D1, and D1 then goes through the output or load, and this goes through this, here touch the wire touched to this coil, and circuit is closed, so no problem, current is goes through, and we get the output, and current goes through this wire. But for second half cycle, current will flow this in this way, so D2 will be activated, and D1 will be D1 not activated, so current will go through this and this wire and along this way, and the circuit is completed. So in both half cycle, for first half cycle, D1 is on, D2 is off, so current we get the output, and for second half cycle, D2 is on, D1 is off, so we get the output. So for both half cycle, we get the output. This is full wave rectifier, means full wave is rectified by this circuit. So in this way we completed the PN junction diode. Thank you to all.